Solve the following problem by using simultaneous equations. State in words exactly what each variable represents. Set up two equations and solve them. A piggy bank contains 24 coins consisting of nickels and quarters. If the total value of the coins is $3.20, how many of each type of coin is in the piggy bank? If you remember our previous chapter, we did solve problems like this using one equation and one variable. I'm going to have you recall how we used the chart to help us define our variables and set up our equations. Remember, we would label the chart with the type of coin, the number of coins, the value of each, and the total value of each type. Now the type of coin that we have nickels and we have quarters. So we will label that right here. And we always try to fill in what the easiest column is to fill in first. So when I'm looking at it, I believe that the value of each coin is easier to fill in first. I know that nickels are worth 5 cents and quarters are worth 25 cents. And keep in mind, since I didn't use decimals to represent the value of a single nickel and the value of a single quarter, that's going to lead me to not have to use a decimal when I use $3.20. So instead of $3.20, it will end up being 320. Now back in the previous chapter, we had multiplied the number of coins times the value of each to equal the total value of each type. So we were told that we had to fill in the number of coins column in order for us to fill in the total value of each type. And we were also told that the equation would come from this particular column. That will still hold, but remember that we have to set up two equations and solve them. So this column will take care of one of our equations. Now, because we are allowed to use two equations and two variables, we can define the number of nickels by using a single variable. I'll choose n. And we could also define the number of quarters by using a single variable as well. So I will choose q for quarters. Keeping in mind that the number of nickels is not necessarily the same as the number of quarters, which is why we're using different variables. So once we have the number of coins column filled in and the value of each column filled in, we could actually find the total value of nickels to be 5n and the total value of quarters to be 25 times q. We can use the total value column to set up our first equation, and we'll do this the same way we did with the previous chapter. So the total value of the nickels plus the total value of quarters should end up being 320. So our first equation will look like this. 5n plus 25q will equal 320. So that is very similar to what we have done in the previous chapter. The next thing to understand is that we need more than one equation in order to solve this system. We have two variables, so we need to find one more equation. So what happens is you then have to look at what other information is given in the problem. So we've already dealt with the money part of the problem with the second equation. So we want to look at what else is given, and this will be the number of coins part. So I'm seeing the piggy bank is containing 24 coins total, and it only consists of nickels and quarters. So whenever you are given a total amount of coins in the problem, you could actually get the second equation from the number of coins column. And if you look at it more carefully, the number of nickels plus the number of quarters should give us 24 in all. So that will be my second equation. N plus Q equals 24. So there are two equations. One equation dealing with the number of coins, and one equation dealing with the total value of the coins. So now we have a system of equations, and we will then have to solve it. So in order to get our system of equations, we use the chart to help us set them up. But I would like to point out that we don't necessarily need the chart to help us set up a system of equations. As long as you are defining what quantities your variables represent, you don't really need the chart if you understand how the problem works. Now keep in mind, once you define what your variables mean, remembering that they represent quantities, which I have an abbreviation for, number of, when you do coin problems, there's always going to be an equation dealing with the number of coins. And that is the N plus Q equals 24. In this particular problem, they gave us the total number of coins, which was 24, and they both consisted of nickels and quarters, so we would add the nickels plus the number of quarters to get us 24. The second part of this problem will give us the value part. So whenever we're looking at this, we could actually see that the value equation is when you multiply the amount of money a single nickel is worth times the number of nickels, and you add it to the amount of money a quarter is worth times the number of quarters, and it is set equal to the amount of money given in the problem. Now keep in mind, we did not use 0.05 to represent how much a nickel was worth. We used 5 instead, and we used 25 to represent how much a quarter is worth instead of 0.25, which means we would have to use 320 to represent how much money is in the piggy bank. So instead of $3.20, it would be 320 pennies. So now that you understand the way the system is set up, you just have to understand how are we going to solve it. And we have 3 techniques on how we can solve these equations. The first technique we can solve using graphing methods. But keep in mind, when you are using graphing methods, you're going to have to plot numbers, and if you see a 320 in the problem, that might make your graph a little bit large. So we usually prefer analytic techniques, or sometimes we call them algebraic techniques, so that we can solve these systems. And the 2 choices would be either the substitution method or the addition, or sometimes we call it the elimination method. So, however you decide to solve this system, just make sure you find what the value of n is and what the value of q is in order to answer what the problem is asking for. Now, my personal preference to solve this system would be to use the substitution method. And you can use the addition method if you'd like. You'll still get the same results. But if I'm going to use the substitution method, I have to remember what equation or what would be easy as to solve for. So when I'm looking at both equations, I'm always looking for a variable that has a coefficient of 1 or negative 1. So when I inspect these two equations, I notice that the first equation might be the easiest one to deal with at first. And then I need to decide what variable I want to solve for. And since both n and q have a coefficient of positive 1, it really doesn't matter. I'll just solve it for n. So if I do that, I have n plus q equals 24. In order to solve for n, I would have to subtract q on both sides. So that will leave me with n equals 24 minus q. From there, I'm going to substitute this equation into the second equation for n. So that will leave me with 5, instead of n, 5 times 24 minus q plus 25q equals 320. In order to finish solving this equation, I will have to use the distributive property to get rid of the parentheses. So 5 times 24 equals 120. And 5 times negative q gives me negative 5q. I'll rewrite the plus 25q equals 320. And from there, I will combine like terms. Let's see, 120 is not a like term, but negative 5q and positive 25q are like terms. So that will leave me with 20q. I'll rewrite the 120. And remember that negative 5q plus 25q gave us a positive 20q, still equaling 320. So to solve, we want to subtract 120 on both sides. So that will leave us with 20q equals 200. And in order to solve for q, we will divide both sides by 20. And that will leave us with q equals 10. Now, we've found the number of quarters. So I'd like to write that down. So that will leave me with 10 quarters. But the problem also asks us to find how many of each type were in the piggy bank. So we not only found the number of quarters, we need to now find the number of nickels. So in order to find the number of nickels, you take the amount you've gotten for quarters and you can plug it into either equation, Or you can go with plugging it into the equation you already solved for n with. So I'm going to do that. Or I could just think about it, if there's 24 coins in all, if I already have 10 quarters, there's got to be 14 nickels. If you want to prove it to yourself, you can plug it in. The number of nickels is going to be 24 minus 10. And 24 minus 10 gives us 14. Just like we had found, the number of nickels is 14. Thank you, Laika. Okay, that's enough. So now we have solved our problem. Our problem has 10 quarters and 14 nickels. My dog wants to help us. So let's finish this off. And now we have the solution to our word problem.